Laminar flow occurs in liquids like, for instance, water. This is where liquid moves in a series of layers. It has implications in many different situations, from how the water moves in rivers to just stirring a drink. At relatively low speeds, molecules in liquids tend to all flow in the same direction with minimal turbulence or mixing. That way, you quickly move down the slope or directly follow whatever path is causing the liquid to move. Any eddy or turbulence that occurs in the path slows the liquid down and it loses energy. Liquids tend to stand almost like cars on a motorway, with each molecule following the one ahead like a train on railroad tracks. This doesn't mean that a liquid flowing in a particular direction is all going at the same speed. If the liquid comes into contact with an irregular surface, there will be friction between the liquid and the surface, which will slow the liquid down. This in turn causes eddies and turbulence as the liquid tries to find an easier path to its destination, and in turn bumps into the neighbouring lanes of liquid. So for instance, in a river with rocks below the surface, this will result in white water as the stream froths and mixes with the air above the stream. So by observing the surface of the water, you can tell if the bed of the stream is smooth or uneven. Now, over time, the flow of the river will tend to wear down obstructions in the river, remove obstacles from the path. However, even when the obstructions have been worn down, the water in the river will still be in contact with the bed of the river and also the sides of the bank. Eventually, these contact points become fairly smooth, but there will still be a considerable amount of friction between the stationary solid surface and the water. This results in the water that's running past the surface moving slower than the rest of the river, but it will still be attempting to stay in the lanes of laminar flow. This results in these lanes of water travelling successfully faster as you move away from the sides or from the bottom of the river, until the water flowing to surface in the middle of the river is moving at a considerably faster rate, as a result, more force driving it than the water near the bank. So while a stream may seem easy to cross when you first step into it, this may no longer be the case when you're midstream and the river is at full flow. This laminar flow also occurs in something as simple as a hot drink, and you've almost certainly observed it, but may not have realised exactly what you were doing or why. In a hot drink, once you've added the water to your mug, you take a spoon and stir the liquid and attempt to mix up the water and whatever you're flavouring it with. However, laminar flow is also occurring in your mug, so at this time the lanes of the liquid follow the circular shape of your mug, being driven by the force of your spoon. However, since all the water molecules are all travelling in the same direction and sticking to the circular lanes, there's very little mixing going on in the water. So in order to evenly mix the drink, you stir the spoon in the opposite direction and set up eddies and turbulence in the water, which disrupts the laminar flow and thoroughly mixes your drink. This counter-rotation or variation in the speed of rotation can be seen in everything from blenders to washing machines, all working hard to counter the laminar flow of liquids.